Good morning, dear students, and welcome back to our today's session of online class. In our previous class, we were studying about preferential or selective discharge of ions at the electrode, and we introduced the three conditions on which the discharge of ions at the electrodes depends, and they are: number one, the relative position of ions in the electrochemical series. That means higher the position in the electrochemical series, lesser will be the chance of being discharged at the electrodes, and lower the position of the ions in the electrochemical series, the greater will be the chance of being discharged at the electrode. And this is what we discussed in our previous class. Like, we have electrochemical series of cations as well as anions. So you can see all the cations of metals listed in the increasing order of ease of discharge at the cathode. So lower the position in the electrochemical series, greater of chances for the discharge at the cathode. In the same way, we have electrochemical series of anions, and like cations, for anions also lower the position in the electrochemical series, with much ease the ion will be discharged at the cathode. So between chloride, if there are ions of chloride and hydroxide, now in the electrochemical series, which one is in the lower position? Hydroxide. So hydroxide will move towards the anode and it will get discharged at the anode instead of chloride ion. So this is what is said by the first condition or condition for the selective discharge of ions at the electrode. The second condition is the relative concentration of ions. The selective discharge of ions at the electrode also depends on the concentration of one particular ion compared to another ion of same nature. Relative means compared to some other one. Okay, for example, let us try to understand this concept. Second condition, say suppose we have cations and anions in the electrolyte. Now say suppose we have two types of cations. Let's say we have, from the list we are going to select, let's say we have sodium cation and we have hydrogen cation, sodium and hydrogen. In the same way, let's say we have chloride anion and hydroxide anion. Now the mixture of these ions is possible when we take, say suppose, NaCl and H2O. So say suppose we are taking aqueous solution of sodium chloride, and say suppose we take large amount of sodium chloride. So when we take large amount of sodium chloride in less amount of water, then we can say the solution form will be concentrated sodium chloride solution, aqueous solution. This means that there will be more number of sodium chloride ions. Okay, so over here now the concentration of sodium chloride is more. Okay, now in this case there are two ions produced over here, sodium and hydrogen. Now when they break up, they will have these ions in the solution. Now the second condition says that The selective discharge of ions depends on relative concentration of ions. So we are taking higher concentration of sodium chloride. Now if you see over here, for the cation, hydrogen will get discharged at the cathode. Hydrogen will get discharged at the cathode. But in the solution, among the anions, chloride and hydroxide ions, chloride ions will be more compared to hydroxide ions. That means the concentration of chloride ion is more compared to hydroxide ion, and both are anions. Now we also know that chloride is at higher position in the electrochemical series compared to hydroxide ion. Therefore, according to first condition, hydroxide ion must be discharged at the anode. But now let's go to the second condition. It also depends on relative concentration of ions. So now let's apply the second condition. So among these two ions, although hydroxide lies lower than chloride ion in the electrochemical series, but the concentration of chloride ion is more than that of hydroxide ion. Therefore, according to second condition, chloride ion will get discharged at the anode. So chloride ion will move toward anode, and over there it will lose electron and will convert into neutral chlorine and atom. And we know that chlorine atom cannot exist independently. Therefore, again another chloride comes, undergoes similar type of reaction, and this is loss of electron. So LO, that means LO stands for oxidation. Again it undergoes oxidation and forms another chlorine atom. Now these two chlorine atom, now they combine together to produce chlorine gas at the anode. So at the anode, the second condition gets satisfied over here, which states that the selective discharge of ion depends on the concentration of ions produced. So here the concentration of chloride ion is more compared to the concentration of hydroxide ion, as a result of which, despite hydroxide being in the lower position in the electrochemical series, chloride ion gets discharged at the anode. So the selective discharge, this proves that the selective discharge of ions at the electrode also depends on their relative concentration of ions. And finally, the third condition says that the selective discharge of ions at the electrode also depends on the nature of the electrodes. So there are two types of electrodes according to their nature, and they are inert electrodes. Inert electrodes means the electrodes which do not take part in electrochemical reaction. They do not undergo any type of reaction during the electrolysis process. For example, graphite electrode made up of graphite, they do not undergo any type of chemical reaction during electrolysis. Or platinum. Okay, these are some of the examples of electrodes, inert electrodes, which do not take part in any chemical reaction in the electrolysis process. Other type of electrodes are called active electrodes. TRODE electrode. Examples of active electrode can be copper, nickel, silver, etc. Now these electrodes, they take part in the electrochemical or electrolytic reaction. These electrodes itself undergo reactions. Therefore, they also influence the discharge of ions at the electrode. For example, if we are taking electrodes made up of copper, okay, and this is an electrode, say suppose, Both the cathode and anode are made up of copper. Okay, and we also take electrolyte made up of copper sulfate solution, aqueous. Now in this particular case, the electrolyte also contains copper, and the electrode is also made up of copper. Now in this type of case, at the anode, and we know that at the anode what type of reaction takes place? Reduction reaction takes place. Now at the anode, the reduction reaction will be effected. There will not be the same type of reaction taking place at the anode when the electrode is not made up of copper. Okay, so at the anode there will be a different reaction. That means different ions or different types of reduction reaction will take place at the anode. And this is why the discharge of ions at the electrode also depends on the nature of the electrode. So you have to remember there are three conditions on which the selective discharge of ions at the electrode depends. Okay, now we'll try to make these three conditions come into reality by taking some examples, some electrolysis example. So we'll take the first example, that is electrolysis of molten lead bromide, PbCl2. Now this lead bromide is melted at around 380 degrees Celsius, and we have the picture also over here. So we use, in this electrolysis, we use inert electrode, that is graphite electrode, cathode made up of graphite and anode also made up of graphite. So this is the electrolysis of molten lead bromide. Now the crucible is made up of silica, because silica is very inert, therefore this crucible will not take part in the reaction. Now let's see what happens when we do the electrolysis of molten lead bromide. So when we take molten lead bromide, now this ionic compound will now produce free movable ions. And what are those free movable ions? Ions will be lead, the valency of lead is 2, so it will produce lead plus 2 ion, and bromine or bromide ion. The valency of bromine is 1, so bromide ion will have 1 negative charge. Now these are the two ions, and we have only these two ions because there are no water. Okay, now these two ions will now take part in the electrolytic reactions. So we have to write reactions at the cathode as well as reaction at the anode. So reaction at cathode and reaction at the anode. Reaction at the cathode, which ion will move toward cathode? TH, cations, CC relation, cations. So the cation over here is lead, so lead will move towards cathode. Now at the cathode, what will happen? What type of reaction will take place? GR, gain of electron. So because lead ion needs 2 more electrons, so it will gain. So here 2 electrons will be gained and will convert into neutral lead atom. So this is the gain of electron, GR. So here it will be reaction. Okay, now this is the reaction at the cathode. Now the reaction at the anode will be, now bromide ion will move towards anode, and over there at the anode it will lose 1 electron and will convert into bromine atom. Now we know that bromine cannot exist in atomic form. It is a diatomic molecule. Therefore, another bromine, there are two bromine atoms in the formula of lead bromide. So another bromide ion also comes towards anode, loses electron, and it also converts into bromine atom. Now these two bromine atoms, they cannot exist in atomic form. Now they will come together, combine together, and they will form bromine molecule like this. So these are the two reactions taking place in the two anode, and here this is loss of electron, LO, therefore this is oxidation reaction. Now oxidation reaction, so what will be the overall reaction? Overall reaction will be lead bromide. We started with lead bromide. This is in molten state, so you have to write L. So lead bromide will convert into lead. This is solid, this one, after the reaction at the cathode, and from the anode what did we get? Br2, this product, final product. Okay, now you just see if it is not balanced. Now you need to balance it by writing required coefficient. Now what will we observe at the cathode? Now at the cathode, what is formed? Lead solid is formed. So the color of lead is silver gray. So what we will observe is at the cathode, this lead, silver gray metal gets deposited, which proves that what is being formed over there? Metal lead. Whereas at the anode, bromine gas will be produced. It will be evolved. And the color of bromine gas is reddish brown. So dark reddish brown fumes of bromine will start evolving at the anode. So this is the electrolysis of molten lead bromide. Okay. Now let us see another example. Electrolysis of acidified water using platinum electrodes. Again here platinum is inert electrode. So this electrode will not take part in any reaction. Now the electrolyte which we are taking is acidified water. Acidified water means to water some acid is added. So water is one electrolyte or one substance, and dilute sulfuric acid is another substance. So the mixture of these two will act as electrolyte. Now over here we could have used instead of sulfuric acid we could have used nitric acid or hydrochloric acid, but the problem is when we use hydrochloric acid or nitric acid instead of sulfuric acid, these two acids are volatile in nature. Volatile in nature means they will change into vapor form and they will escape the electrolyte, therefore reduces the electrolysis process. Hence dilute sulfuric acid, which is non-volatile, is preferred in the electrolysis of acidified water. Now if you carefully notice over here, water is also a covalent compound and sulfuric acid is also a covalent compound. So here these two compounds, they do not have any ions with them, so therefore they undergo ionization. When we make a mixture of water and dilute sulfuric acid, they will undergo ionization, which we have already discussed in our earlier class. So now they will create ions. So what are the ions present? Let's see. So from water, one compound is water. So water will ionize to give H plus and OH minus ions. Okay, so these are the ions produced after ionization of water. Now again there is sulfuric acid, so H2SO4. So this sulfuric acid also gets ionized and it has two ionizable hydrogen, so it will produce 2H plus and 1 sulfate ion. So altogether we have two cations and they are H plus from water and 2H plus or H plus. That means we have only one type of cation. Okay, one type of cation in the electrolyte. What about anions now? Let's see anions. Now we have one anion OH minus and another ion sulfate ion. So for cations there is no problem, we have only one type of cation, that is H plus. But for anions there are two types of anions, OH plus and SO4 minus 2 ions. Now for the reactions taking place at cathode, let's start. A reaction taking place at cathode, at the cathode. So there is no confusion which ion will get discharged at the cathode. Cation, CC relation. So H plus will move towards cathode. Now this is less in it has less number of electrons, so it will gain electron over here. So it will gain electron and it will convert into neutral atom. Again, we know that hydrogen does not exist in atomic form. So again, another H plus ion comes to cathode, it again gains electron and convert into H plus ion. Now these two H plus ions, now they will combine with each other, hydrogen atom, they will combine with each other to produce hydrogen molecule, and it is a gas. So at the cathode, which gas will get produced? Hydrogen gas will get produced. Okay, now let's see, this is what type of reaction? Gain of electrons. So this is, whole thing is reduction. Now at the anode, now we have two types of ions which can move towards anode and get discharged. But now we will take the help of electrochemical series of anions. And according to electrochemical series of anions, sulfate is at the top whereas hydroxide is at the bottom. And what does this signify? That hydroxide ion will get easily discharged at the anode. Therefore, out of sulfate and hydroxide, which one will get discharged at the anode? Hydroxide ion. So let us use that concept and write the reaction of anode. So at the anode, hydroxide ion will move towards anode instead of sulfate ion. Now this has one extra electron, so it will lose that electron and will convert into hydroxide OH. Now this cannot exist in nature. Again, another OH, hydroxide ion, comes to the anode. It also loses one electron and it also converts into OH. Now these two will now come together and they will produce water, H2O, and oxygen, H2 and 1 O. So it will produce one molecule of water and one atom of oxygen. Again, one atom of oxygen cannot exist independently because oxygen is a diatomic gas. Therefore, what happens is, again, this whole process takes place. Again, OH minus, one OH minus will come, lose OH. Another OH minus ion comes, it again loses electron and converts into OH. So these two again combines, OH plus OH gets combined and produces H2O plus O. Now here there is one oxygen atom and here we have another oxygen atom. So now these two oxygen, O plus O, combines together to produce oxygen gas. Therefore, which gas will get produced at the anode? Oxygen gas will get produced at the anode. Okay boys, so the overall reaction I'll write over here. This whole thing can be written as, how many OH ions has taken part? 1, 2, 3, 4. So 4 OH minus ion. One OH minus loses one electron, so 4 will lose 4 electron. And how many water molecules are produced? 1 and 2, so 2H2O plus oxygen, one oxygen molecule, and this gas will get liberate at the anode. So this is how the electrolysis of acidified water takes place using platinum electrode. Okay, so if a question comes to you like write the product form at the anode during the electrolysis of acidified water using platinum electrode, what will be the product? Do not write OH, do not write water, do not write O, because O does not exist. What you have to write? Oxygen gas. Which gas will be produced? Oxygen gas will be produced. Which gas will be produced at the cathode during the electrolysis of acidified water using platinum electrode? Hydrogen gas. What type of reaction undergoes at the cathode? Reduction. What type of reaction undergoes at the anode? Oxidation. Write the reaction. You have to write like this. Am I clear, boys? I hope I have made you clear about how to write the electrolytic reactions at different electrodes and how to determine products formed using the conditions required for selective discharge of ions at the electrode. We'll discuss about electrolysis of some other compounds in our next class. This much for today. Stay safe and do all things well.